Yeah, so my name is Seth. I've been doing Scala a long time. I've been on the Scala team at Lightbend for the last few years, moved to San Francisco a couple years ago. It's wonderful to be back in Boston, where I lived for 10 years, and it's really wonderful to be speaking at any Scala, which is still really, really close to my heart. It's the best conference. The topic today is compiler plugins, starting from zero. If that's possible in 30 minutes, I have more material than I can possibly cover, so there's going to be some things on some slides that will fly by very fast and some things on slides that I won't talk about. So those are, material that you could look at later if you like. The idea for this talk came about because at my job I ended up writing several compiler plugins. One of them is called Sculpt. It's for analyzing the internal structure of your code, dependencies within the code. I have a separate talk on that called Tools for Taming Tangled Code. And the other one is a commercial product called Fortify. It's a static analyzer that looks at Scala source code and tries to find mistakes in it that could lead to security holes in software. That was a collaboration with Micro Focus. And then I actually wrote a third plugin recently for the Scala community build, which I'm the primary maintainer of. We wanted to know how many lines of code were in this big build that aggregates lots of open source projects. We couldn't just run CLOC directly because the community build doesn't build all of every included project. So this little compiler plugin counts the lines of code in the in only the files that you actually compiled. Once I got that done, I ran CLOC on itself and found that it was surprisingly small. It's only 45 lines of code, 41 Scala, 4 XML. And that was sort of the idea for the talk, is I could show how easy it is to write at least a minimal Scala plugin. Of course, the difficulty level rises from there. Okay, so hopefully this will be interesting whether you're just a user of plugins, which probably 100% of you actually are, or whether you have an idea you might like to actually write one. This is a new talk. The material in this talk will also be feeding into a blog post and into improved documentation on compiler plugins. So I'm mentioning that up front because I would really like feedback and suggestions on this, because it won't just be like, oh yeah, I should have done that. Like I'll actually be able to use your suggestion, not only when I give the talk again, but also any suggestion about the talk that will probably also work as a suggestion for documentation and blogging. All right, what are plugins? What do we use them for? I did an informal survey of what compiler plugins are out there, and these are ranked by GitHub stars. Not a perfect metric of popularity, but it's easy. So there are stars on a few of these. So these are all compiler plugins. Star on SBT because it's Zinc. It's technically not a plugin, but it should be. It could easily be refactored to be one. So I thought it was worth including. And I wanted to put in ScalaFix because it's really important. It's built on top of a compiler plugin. There's a thing called Semantic DB. So Oliver wanted me to be clear on that point, but it is like critically, there's a compiler plugin in it that's critical to its functionality. Before I go any further, I'm just curious: is there any currently active plugin that you're using or that you like that's not on this list? Did I miss anything? Diesel for tagless final. Diesel. Okay. Dan is telling me Diesel for tagless final. So I had heard of Diesel, but had no idea there was a compiler plugin in there. Thank you. Anything else? Yes.
T-Cat, there's a plugin that sets some Scala C flags, which is nice.
Sorry, what's the plugin called?
T-Cat SPT, but I guess that's SPT.
Oh, okay, I'm not sure. I'll look it up afterwards and see. Yes? In back? Oh, there's that's like a silhouette of someone waving their hands in the other room. All right, so that list of plugins, some of them you may have heard of, others not. I tried to categorize them to give an idea of the space of possibilities that plugins are capable of. So I've got some fine categories and broader categories. The first three rows are compiler plugins that actually alter the language. Kind Projector and the applicative syntax plugin add new syntax to Scala. Scala continuations and two-tails give a different meaning to existing Scala code. And then Macro Paradise is a metaprogramming facility that allows other people to build extensions that make additions or changes to the meaning of the language. The second group is the biggest. These are plugins that don't change what code, what you can do, but just help you do it better. So there's a lot of linters that are plugin-based, plugins that make improvements to how errors and warnings are reported or handled, generating code, generating documentation, and then Scala Meta is another. This is another meta thing that lets other people build tooling. They build the plugin, and then you take it from there. And then at the end we have just miscellaneous stuff. So Zinc, as I mentioned, is the incremental compilation part of SPT. It's also usable by other build tools. And Scala.js and Scala Native are compiler plugins. So these are alternate backends that compile Scala code to JavaScript or to native code instead of to the JVM. So hopefully that gives you some idea of the space of what's possible. The most common way of using a compiler plugin is actually what you add to your build is something that says add SBT plugin. And because this is so common, I think often people don't even know that a compiler plugin, whether a compiler plugin is involved or not. Compiler plugin authors do this for two reasons. One is that, as we'll see on the next two slides, the way you add a compiler plugin to your build directly is a little awkward. So the authors like to make it easier. But it's also common that if you have a compiler plugin, that you also want some extra stuff, some extra settings and tasks in your build to help you interact with it. So that's why this is so common. Of course, every one of these plugins has a README on GitHub that tells you, what to stick in your build. Adding a compiler plugin directly looks like this if you're using SBT. It's just add compiler plugin, and then not all plugins take options, but some do. If they do take options, they take them as extra flags to Scala C, so you just mix them in with your other compiler options. But it's clear that it's a flag for a compiler plugin because of the -p, P for plugin. So SBT here is providing a little bit of magic itself when it says add compiler plugin, but it's actually very little magic. It's worth understanding what add compiler plugin actually does. So all it does is it adds the library to your library dependencies, but under a special configuration, and that configuration is what ensures that the plugin is only on your class path during compilation. It's not on your class path at runtime, which you obviously wouldn't want. So that's all it's doing. Oh, and so it does one other thing, which is fill in these X plugin options to enable the plugin. So you've got one to enable it and to give the path name to the jar, and then another to say, yes, I really want this plugin. Why these are separate flags, I have no idea. So this is SBT syntax, but you would just do the same thing in a different build tool, but just with whatever that build tool syntax is. I have a few. I mentioned that you may not know that you're using a plugin. I have a couple slides on how to figure out which ones you're using. You can. I'll skip those, but you can refer to them if you're curious. Okay. As a plugin user, here are some things that you should probably consider before adding one of these plugins to your build. Compiler plugins, they can impact your build times. There's an improvement on that in Scala 2.12.5 that I'll come back to at the end of the talk. I would recommend measuring it because it's a lot easier to catch these performance things, at the time you first introduce something rather than, 2 years later you're like, my build's slow, and then try and figure out when it started. You should find out whether the plugin supports all of Scala. I think for the kind of linter style plugins, they usually do for plugins that rewrite code. It's more common that there are edge cases where it's just like, where it's like, oh, if you're writing normal Scala code, you're fine, but the plugin gets confused if you, if you use this particular construct. Compiler plugins that rearrange code are actually quite hard to write and difficult to get 100% correct, so that's why I make that caution. It's very rare for there to be any binary compatibility concerns with plugins. Usually the plugin authors are very concerned that not happen because then people wouldn't use it, but you might check. You should find out whether it's friendly to the tooling you're using. Again, that's mostly about plugins that make alterations to syntax or semantics. It's like, oh, it works, but now it's red squiggles in IntelliJ or something. You might try and find that out. It is possible to write an IntelliJ plugin that goes along with your plugin to like tell IntelliJ about the thing that you added. So it's not necessarily an either-or choice of whether you're going to lose IDE stuff by enabling one of these things. And then you might also think about and this is true of adding any library or any programming technique really. Just consider whether you're sort of fragmenting splitting yourself off from the rest of the community or your company or your team by doing something special. So that's the what are plugins, using plugins part. Are there? Can I answer any questions on that before I start talking about how to build them? Okay. Before building a plugin, you might first ask yourself whether you should. There are alternatives. A particularly new alternative is Scala Meta. Scala Meta is only a few years old, but that makes it newer than many of the popular plugins on the list I showed. Until recently, Scala Meta was syntax only. It didn't know anything about types, and so that really narrowed the range of situations where it applied. But within the last year or so, Scala Meta now does understand types. So there is a compiler plugin that it includes now called Semantic DB that runs after the typer phase of the compiler, so you know, Scala Meta knows about types. It's fairly new, it's still being improved, so there is a possibility if you decide to go that route that you'll end up like, you know, reporting bugs to Oliver to get it fixed. But it would be great to have more people using it just to shake out those issues and get it over the finish line. Currently, the development work on Semantic DB and on Scala Meta is primarily driven by ScalaFix, which is you know, really core to the future of Scala. We're really counting on it to help people migrate to the new collections API in Scala 2.13, and to help people migrate to Dotty when it becomes Scala 3. So I do think that this, although Scala Meta isn't perfect yet, it does have its future is assured because we're already counting on it. Another alternative to consider is macros, either just plain macros, the kind that are considered experimental but are, you know, part of the Scala compiler, and they've been in there since Scala 2.10, so they're very well established, and they're, you know, not going anywhere, at least until Dotty lands. And then also Macro Paradise, which is a separate compiler plugin that you depend on that, among other things, permits defining annotation macros. So you put an annotation in your code, and then it causes that section of the code to be rewritten. So go one of those routes first if you can. And those are the fact that these. Well, the fact that macros exist is why the category of like code rewriting plugins is now fairly short. It's because people have gone over to macros instead in most cases. As for that big section of the linters and other tools, I think that list is going to shrink in coming years. So I think more and more of those sorts of tools are going to not be compiler plugins directly, but be built on top of Scala Meta. All right, but you're determined. You're going to build a compiler plugin. You Google the documentation, and you find that there's a nice tutorial, except the tutorial was written in 2008. Oh, and that was supposed to be a stream emoji, but apparently I'm having a font problem. Okay, and if you look on the Scala documentation site, where you might expect to see documentation on compiler plugins, there is a blank space, also a stream. I hope my other emoji don't fail to render. Okay, so compiler plugins, not very well documented, but I have a pull request that fixes that, so let's fix that. Not whip anymore. Not for merge yet. Merge. Okay, branch deleted. And so now that should be live on docs.scalalang in about like 3 minutes, and when it's live, it will look like. Oh, please take me back to the slide I was on. Yes. Okay. So the real site will look like that in a minute or two. And I did actually update it. You know, it's like it's not perfect, but I did remove anything that was like blatantly false. And so it's okay now, and it'll also be getting better now that I've done the work on the talk. Okay, so what can your plugin do? What can your plugin do? Because this is the JVM, it's not possible to just arbitrarily reach into anything in the compiler and change its behavior. Scala and the JVM just don't work like that. The thing that you can do, like basically the only thing that you can do, is insert one or more new compiler phases, and those will run between the existing phases in the compiler. The good news, or the bad news, depending on your point of view, is that when you define that phase, it will have access to NSC global. NSC is new Scala compiler because it was new like 13 years ago. And from that, you have access to everything. You can do anything. So you're limited by when you can do something, but you're not limited at all by what you can do. If you run Scala C X show phases, that prints out a list of the phases. I've shortened the list because there's a lot, but really the only two that we care about are typer and JVM. So typer is when your code gets type checked. Before typer, syntax only. After typer, you've got types, but your code is still looks the same. Then, in the middle of the compiler, it gets transformed a lot. And then at the end, we generate bytecode. I classified most of the plugins on that list I showed according to when they run. So a syntactic plugin runs before typer. Linters typically run right after typer because they want to be analyzing something that has types but is still much like what you wrote. Alternative backends like Scala.js and Scala Native, those run right before bytecode generation. And I could only find one example of something that ran after bytecode, which is S coverage. So that injects instrumentation into your bytecode. So hopefully that will help you decide when your plugin should run. Let's take a look now at a sample plugin, and it's short, so there's really not very much to look at, thankfully. So to write a plugin, this is mostly boilerplate. The outer class is plugin extends plugin. Here's where you get your global that gives you superpowers. Inside plugin, you have component. I have no idea why plugin and component are separate. That's actually being removed in the Dotty version of this, so don't worry about it. Just do it. Here's where we specify what phase we're going to run at. Note the repetition of runs after and runs right after. This is important because if you only say runs after, it's like sometime after, and so it might end up running later than you expected. And yes, you have to use them both. It's weird. This is the kind of thing that's really important to have documented. Okay, so, and then inside the component, there's a third layer, which is the phase. A simple plugin will have only one phase. And in that phase, you really are just implementing two methods. The run method runs once per entire compiler run, and the apply method runs once per compilation unit. So a compilation unit is basically one source file. So for counting lines of code, it's very easy. Every time we see a source file, we throw it on a list, and then all the way at the end of the run, so after calling super.run, we run through those files and count the lines. Watch out for this little trap where your plugin will run even when generating Scala Doc unless you tell it not to, because Scala Doc is like a part of the compiler. The rest of the code is just the stuff that actually runs the lines of code counting tool. I'll show one other. And so this is all in a Git repo. I've showed you the code, but of course, equally important is the build stuff that makes this happen. That's all in the repo. It's not interesting, but you can just clone this repo and use it. I'll show one other bit of example code. This is from another little example plugin by Jason Zog called Boxer. It's designed to tell you when when you have a value class, but your value class got instantiated, which means that you lost the performance benefit that you were hoping for. Writing something like that turns out to be surprisingly easy because the compiler includes this class called traverser. So that takes care of all the mechanics of walking through all of the nesting in your code, package, class, method, expression. It walks the AST for you, and then all you have to do is write one pattern match that says, this is the kind of AST node that I'm looking for. We also see there are two other sort of fun things here. One is, well, this shows you how to report an error or a warning, and then this also shows that, exiting typer. So this shows that the compiler has time travel. You can ask, even if you're running at a later phase, you can say, well, what was the value of this thing at the earlier phase? And if you're lucky, the answer is actually correct. But Jason knows what he's doing, so this one must be correct. Okay, so I have really very little time left. So what do I still have time to talk about? We've seen the sample plugin. You need a little XML in order to have a working plugin. That's shown in the repo. For testing, the easiest way is to just publish local the thing and then add it to some other build. The other testing strategies are harder, and I didn't really have time to get into it, but here's the basics, and then I'll document this better later on. For debugging, if printline debugging fails, just attach a remote debugger. Don't try to get IntelliJ to build your plugins. It's really a lot easier to just tell it to attach to a running JVM. When you publish your plugin, please do it by Scala minor version, because compiler internals change, so you can't assume that your plugin won't break when 2.12.5 comes out. All right, so I have to leave you there. Sorry, step one's easy. Step two, you're on your own, or actually you're not on your own. We'll help you on the contributors discourse forum. That's a great place to ask questions about this kind of stuff. I'll skip these slides. This are like, okay, so to actually draw the owl, I need to know about compiler internals. I have 4 slides of advice on that. So here are things to try. Here are talks to watch. Here is documentation to read. All of these things will help you, not only if you're writing a compiler plugin, but also if you just want to use Scala reflection, write macros, hack on the compiler. It's all the same material. Dotty doesn't have a plugin API yet. It will soon. There's an open PR you can look at if you like. It's very similar to the existing API. Okay, and I have time for one more thing. Scala 2.12.5 is I don't know, might actually be out since I started talking, or maybe tomorrow. It adds 2 new flags that we found can speed up compilation times on some projects by as much as 35%. So huge win on some projects, but you have to turn these flags on. They're not on by default. We expect they will be on by default in Scala 2.13, but we're not sure yet whether they're safe. In particular, there may be plugins or macros out there in the wild that actually break because they're making some assumption about class loaders that this change violates. So we would love to hear from you if you try this, and if something breaks, or if nothing breaks and you see a great speed up, we'd love to hear from you on the discourse forum. Again, Scala 2.12.5, that's coming out, any minute or day now. Thank you for listening. And I think I might have finished. I've got 1 minute for questions. I'm going to be here. I'm going to be at the Drink Up tonight, and I'm also going to be at the Type Level Summit all day tomorrow. So I'm available for questions like that, and I have time for 1 or 2 questions right now. Yes, Dan.
We're using something that is using a compiler plugin like Macro Paradise. Is there any good way to debug it if something goes horribly
Okay, so the question is, if I'm using a plugin like Macro Paradise, how can I debug it if it goes horribly wrong? I mean, so I mentioned that you can attach a remote debugger, but obviously that's the last resort, right? You really don't want to be stepping through compiler code, wondering what went wrong. There are a lot of compiler diagnostic flags that you can enable that will print out more information. There's -x print, which will print out how code looks after each phase of compilation. That's very useful. There's, I'm not going to remember the exact names of these flags, but there's one that's like explain typer. There's one that will give you a trace of implicits being searched for. There's a lot of, that could actually be a whole other talk of like useful compiler flags. It's an incredibly under-documented area of Scala. So yeah, that's the 30-second answer. One more. Yes?
List of recommended reading for things like that.
Oh, sure, yeah. So yeah, symbols, trees, and types, that's in the official docs. That's like the Bible. And these two talks, they kind of cover similar ground. They're both good. Each of them is about an hour long, and they show, well, I haven't seen Chris's talk in a while, but I know that Jason's talk is not just like, it's not just like a lecture, like, you know, here's some material for you, but he actually, everything is in the REPL. It shows how you can actually interactively explore and experiment with compiler internals. It's like fun stuff, even apart from the educational, help me write my plugin aspect. It's also just cool. Okay, thanks.